All right, what you're looking at here, the topic of today's video, continuous functions. Okay, so there's two sides to this topic. There's what a continuous function looks like, and then there's some math that goes along with that. And I think for most people, it's easier to understand what a continuous function looks like. Okay? The math's a little bit harder, but everything here about the math that goes along with a function being continuous is consistent with everything you've learned in calculus up to this point. All right? So it shouldn't seem like it's different. We're just going to be reinforcing some stuff you've already seen. Anyway, so let's talk about first what a continuous function looks like. This function, just which I've sketched here just for the sake of illustration, is continuous at all points because there are no breaks in the graph and there's no holes or missing points. I mean, it's that simple. If there was, say, like look at this one, a point missing, then this particular function will not be continuous at the spot where x is equal to 2. Like that hole right there is located at, right above 2 on the x-axis. Okay, so that function's not continuous at 2. It's continuous everywhere else because there's, as far as I've drawn it, there's no other points missing, but it's not continuous at 2. All right. Well, maybe a more technical way to say that, f of 2 is undefined. If you had this function, like say you had some formula for it, all that would mean is that apparently when you plug 2 in for x, you wouldn't get an answer, right? It would be undefined. So that's what a continuous function looks like. I mean, here's what it doesn't look like. What's another example? This function, also not continuous at 2. There's a break in the graph. The graphs are disconnected. They're disjoint. Okay? Is f of 2 defined? I might as well talk about that. I mean, we're going to be getting into it. Is there a hole in the graph? I mean, that point is absent, but in this function, according to the information on this graph, if you're going to take the graph at face value, what is f of 2? Is it undefined or not? Well, according to this point being there, if you let x be 2, you get y be 3. So you get an answer when you plug 2 in. It's not like that one. But nonetheless, the graph is in 2 disconnected pieces. And that makes it not continuous at this spot. It's not continuous at 2. Okay? All right. So that visually, that's the way things go. What about the math? All right. So I'm holding you accountable to know the math. If a function was continuous at a particular point, let's call that point x is equal to a, where a is some number. 3 things have to happen. If these 3 things happen, it's continuous at that point. If any one of them doesn't happen, it's not continuous at that point. What are the 3 things? Well, when you plug a in, you have to get an answer. What if you didn't? Well, there would be a hole in the graph, and it wouldn't be continuous. So at the bare minimum, for a function to be continuous at point x is equal to a, you've got to get an answer when you plug a in. Second thing that has to happen, the limit as x goes to a has to have an answer. What do I mean by have an answer? Well, it can't not be, does not exist. Can't be, does not exist. Sometimes when we calculate a limit, we say the limit does not exist. Okay? So long as there's an answer to the limit, it passes the second part of the test. All right. What's the third part of the test? The answer you got there has to be equal to the answer that you got there. And if you can say yes to each of these, if it passes each part of the test, it's continuous at the point A. All right. So that's just in a nutshell what has to happen. Now, this is, I guess I want to practice both sides of it. I'd like you to be able to see what things look like, and I need you to be able to do the math also. All right, so we'll look at some examples that involve doing just that. All right, here we go. So first example, take this function as it is. Is it continuous at x is equal to 2? Okay, is it continuous at 2? I can tell right away it's not, and I hope you can too, because you can't even plug 2 into this function. It's not included in either if, right? You use this formula if you put in any number less than 2, and you use this one if you put in any number more than 2. But what do you do with 2? There's no instructions, so there's no answer. Okay, so as far as it being continuous at 2, no. All right. So I'm comfortable giving that answer, right away. So let's say it's not continuous at the point x is equal to 2. Not continuous at 2. There's my answer as far as whether it's continuous at 2 or not. Okay, it's not. All right, now but I want to give you more detail about that. All right, so how about this? Let me draw the graph, because that's something I want you to get used to, and then I'll also go through the math, and I want you to be able to do both things. Okay. Okay. As far as the graph goes, let's sketch it out like this. If I could draw it for you, and if you could draw it, it'd be real easy for you to tell whether it was continuous or not. So I need to sketch out y equals x to the third power if x is strictly less than 2. Okay, where's that graph going to end up? Like, let's put 2 right here. Like, it's going to do whatever it does. Where's that like final point? Where's the end of it? Well, like, what if you put 2 in? You'd get 8. I know you can't, you're not supposed to put 2 in, but if you did, you'd get 8. So here's what that suggests, that there's a hole right there. And all the other points where x is less than 2, such as at 1.9 and 1 and 0 and so on, they just lead up to that. Now, if you sketch those points, it's going to look something like that, all right? My scale's not perfect here, but it's going to look a lot like that. What about this other one? How do you sketch x plus 6 if x is greater than 2? Well, what's the first point that we should start with? Let's put 2 in, and whatever we get, we'll have to leave that open, and then the rest of the points will fall into place with numbers bigger than 2. So if I took 2 and I put it up here, 6 plus 2 is 8. So this one picks up where that one leaves off, at 8. From there, it's a straight line. It has a y-intercept of 6, and you could plot points and connect the dots and so on, and it's going to look something like that. Okay, all right. So there's an accurate picture of what that function looks like, and we can tell that, like, look right there, right? See that hole? All because of that, it's not continuous at 2. Okay. Now, I had already said that. I could tell that it wasn't going to be continuous at 2, because no matter how the rest of these points fell into place, there's just no answer there. There's no point at 2 on the x-axis. There just isn't, and for that reason, it's not continuous at 2. Okay? All right, so this is what it looks like, okay? But I need to make sure you can do the math. And what do I mean by that? You'll need to go through each part of this test, tell me what you get, and make a conclusion. Okay? All right, so here's the, like, visually why I think the answer is it's not continuous at 2. And then down here, I'll do the math, like strictly the math, okay? So what 3 things have to happen for this function to be continuous at 2? First thing that have to happen, if this function was continuous at 2, I would have to get an answer when I plug 2 in. Second thing that would have to happen is the limit as x goes to 2 would also have to have an answer. And the third thing is the answer I got for part 1 would have to be equal to the answer I got for part 2. If I could answer yes or affirmative to each of those, the function would be continuous at 2. Well, let's go through them. So first part, what's f of 2? What answer do you get when you plug 2 into this function? Well, we've already discussed this. It's undefined. You don't get an answer when you plug 2 into that function. So it's undefined. Okay, so right off the bat, it fails the first part of the test. Okay? If it fails any part of the test, it wouldn't be continuous at that number, 2 in this case. All right, so that would make doing the next 2 parts unnecessary because it already failed the test. It'd have to pass all 3 to be continuous, and it failed the first part. But still, I'll do the others just because for practice. I need to make sure that you can do it. So let's say we'll go and we'll answer part 2 anyway. What is the limit as x goes to 2 f of x? Okay. What's the limit as x goes to 2? What's that mean? It says if x is microscopically close to 2, where is y? In rough terms, that's what this limit means. Well, look at the picture. If x was 2.1, what y would you be getting? Something like slightly bigger than 8. And say x was 1.9, what y would you be getting? Something slightly below 8. Like all the x's near 2 are going to give you y's up here very close to 8. So that limit has an answer. It's 8. So it's like it passes that second part, fails the first part. Third part, is the answer you get here equal to the answer, well, is undefined equal to 8? No. So it fails the third part too, if just to say pass or fail. Okay, so there's the math. Now, I need you to know both sides of it. I'd like you to be able to sketch the picture, see what it looks like. It's real easy to see it's not continuous, but I need you to go through each part of this test and say pass or fail and make a conclusion. Okay? All right, let's try another one. So here's different function. Is it continuous at 2? So this time, like, I at least get an answer when I put 2 in. In this function, what do you get when you plug in 2? 2 would fall under these instructions. 2 plus 1 is 3. You get an answer. There's not going to be a hole in the graph like that one. All right, but that doesn't mean it's continuous. That doesn't mean it's in one solid piece. So I'm going to, seeing is believing, so I'm going to go ahead and sketch it. And let me make sure that we're looking at the same thing. I need to draw x plus 1 if x is less than 2. So I'm going to go up to 2. That's where that very last point is. 2 plus 1 is 3. So let's put a point up here. 2 for x, 3 for y, right? 2 for x, 3 for y. That point is on there. It's part of that function. You plug in 2 for x, you get 3 for y. The rest of it, all the other points on that for x less than 2, it's a line. It has a slope of 1 and a y-intercept of 1. It's going to look like that if you plot it. Okay, and what about this one though? This one picks up from 2 onward. What's the very first point that we get out of that for x greater than 2? Well, remember, we put, even though 2's not technically allowed here, we'll put 2 in. 1 minus 2 is negative 1. So like down here at negative 1, we'll get this point that's open. If you were to put 2 into that formula, if it was allowed, you'd get negative 1. Since you can't, we know that's open, and all the other points bigger than 2 are going to pick up from right there. What are the other points? You could plot points like what if you put 3 in? 1 minus 3 is negative 2. It's a line that's going to go down from here. So it looks something like this. I know my scale, as I sketch this out, is not perfect, but that's what it looks like. Okay. Is this... Now you're looking at it. There it is. Is this continuous at 2? Well, I mean, obviously not. See this break? It's not in one solid piece. You know, just because of what happens right here, we could say it's not continuous at 2. Okay. So I'll make that my answer. There's my response. Is the function continuous at 2? No. See, it's not. All right. So that's the visual treatment. That's looking at it. Let's make sure we can do the math. I need to see whether or not it passes each part of the test. Okay. So over here we'll do the math. What math has to be true for this to be continuous at 2? Okay, 3 things. First thing, that has to have an answer. Second thing, this has to also have an answer. Third thing, this answer from part 1 has to be the same as this answer from part 2. If it passes each part of this test, it will prove that that's continuous. Obviously it's not, so it's going to fail at least one part of this test. Let's see. First part, what's f of 2? In this function, what do you get if you let x be 2? You get 3. So, okay, 3. So it passes this first part. Okay, so far so good. What's the limit as x goes to 2, f of x? What's that mean? Means if you let your x's be microscopically close to 2, 2.1, 2.01, 1.9, 1.99, where are the y's? What number are the y's close to? Well, if the x's are close to 2, it's not going to put the y's close to any one particular number. Like, what if x was 1.9 or 1.99? You're going to get whatever those y values are, which look like they're about 2.9 or slightly less than 3. What about on the other side? What about 2.1 or 2.01? What about these numbers that are close to 2? Well, they're going to give you those y's, and they're negative 1. So putting the x close to 2 is not going to put the y close to any one particular number. If we made a table, the y's wouldn't be meeting in the middle, converging on the same point, all right? So this is the kind of example where we say the limit doesn't exist. Okay, well, failed that part of the test, right? To pass each part of the test, this is supposed to have an answer, that's supposed to have an answer, and then they're supposed to be equal. Well, it's failed that part. It's going to fail this part because is 3 equal to does not exist? Obviously 3 is not equal to does not exist. Okay, so those are the ways that you can see it, right? And I need you to know both. Conclusion, it's not continuous at 2 because of failing this test. or because the way it looks. All right. Okay. So let's look at a few more. I just want you to see all the ways that this can happen. So let's look at this one. All right, is this function continuous at 2? So let's treat it like the others. We'll sketch it out real quick, and we'll probably have a pretty good feel of it once we sketch it, and then we'll do the math, and it'll be like the others. So, okay, so what's this look like? I need to draw y equals x plus 1, leaving off the point where x is 2, leaving only that point off. What point am I leaving off? What would that give you if you put 2 in? You get 3. But that, and only that point, gets left off according to this. Okay, what's the rest of it? Well, so y x plus 1, that's a line. It has a slope of 1. It has a y-intercept of 1. But it's a line, right? So to do this much of it, looks like that. It's missing that point, 2 for x, 3 for y. Okay. What about the second part? Second part says y is 5 if x is 2. So that's telling me that there's just this singular point right there. Y is 5 if x is 2. Up, right there. Okay, that's what it looks like. It's not continuous, right? Not continuous at 2. Okay. Well, because it's not solid. If it was continuous at 2, it'd be one solid piece. There would be no holes or displaced points or anything like that. Okay? So from looking at it, I can tell it's not continuous at 2. All right. So we got the picture down. Hopefully you can agree with my conclusion that it's not continuous at 2 just based on the way it looks. What about the math? You need to make sure that you can do the math. What has to happen? If it was continuous at 2, well, f of 2 would have an answer. Limit x goes to 2, f of x would also have an answer. 3, that answer would be equal to this one. Let's see. Does f of 2 have an answer? In this function, if you plug 2 in for x, what do you get for y? You get 5 for y. F of 2 is 5. Okay, pass. What about this one? What's the limit as x goes to 2? So what's that mean? If x was close to 2, 1.9, 1.99, 2.12, close to 2, near 2 but not equal to 2, where would the y's be? Look at this picture. If x is close to 2, like say 2.1, 2.01, slightly bigger than 2, you're going to get your y coordinates right here, extremely close to 3. What about on the other side, 1.9, 1.99? You're going to get your y coordinates right there, also very close to 3 from this picture. If x is close to 2, that will put the y close to 3. Okay, so the limit is 3. If x is close to 2, y is close to 3. You might say, shouldn't the limit be 5? Because when x is 2, y is 5. Well, the limit just says when x is close to 2, not equal to 2. Okay. All right, now I actually want to make a note about that. I just feel better doing it. So for me to give this answer means if x is close to 2, then the effect will be that y is close to 5. All right. You could make a table to demonstrate that if you want to. I think it's all given away on the graph, but you could make a table. All right, so it actually passed the second part. This has an answer, that has an answer. What's the third part? This answer has to be equal to that one. Well, 5 is not equal to 3. It fails the third part. Okay. I knew it was going to fail one of these because, as a matter of fact, it's not continuous at 2. It's going to fail one of the parts, but it turned out it was the very last one. Okay. So why isn't this function continuous at 2? Well, you can look at it and you can tell that it's not, but if strictly by the math, it's not continuous because of failing that third part of the test. Okay. Let's do let's probably do 2 more that are like they kind of in the same spirit of what I've done so far. Okay. All right. So is this one continuous at 2? Like, can you make a judgment right away that it's not continuous at 2? Like, what's the very first thing that has to happen? When you plug in 2 for x, you got to get an answer for y. If you don't, there would be a hole or a point missing in the graph. In that function, if you plug in 2 for x, you don't get an answer. I mean, you get 0 over 0. It has no answer. Okay? All right, so it's not going to be continuous at 2. Bottom line. For that reason. Now, but let's explore it. I mean, I can say that real quick, and that's true, and that's the answer. But let's look at it the way we've been doing. So earlier, like I guess in an earlier lesson, I took this function, I broke it apart a little bit. And here's what I mean. Like, I can reduce this way. X plus 2, x minus 2 over x minus 2. And we can cancel that and just say it's x plus 2. But we can only cancel this if it's not 0 over 0. And if the x was 2, it would be 0 over 0. So I can say this is equal to that as long as I don't plug in 2, right? So like as a piecewise function, we'll say this thing is just like that thing so long that you don't put in 2. What is this thing equal to if you do put in 2? It's undefined. Okay, undefined if x is equal to 2. All right. So let's sketch it out this way and then make our judgment from there. We'll do the math and I'll look at the picture and so on. So this graph right here, x squared minus 4 over x minus 2, what does it look like? It looks like this line with that point left off. What is that point? 2 for x, 4 for y, right? If you were to put 2 in, you'd get 4. But we've got to leave that one off because, in fact, this thing we started with, you cannot put 2 in. But so far as it reduces to this, and it's otherwise equivalent to that, without 2, if all the other points have got to be near 4. What are the rest of the points on x plus 2? It's a line. It has a slope of 2 and a y-intercept of 2. It looks something like that. What about the second part? Well, the second part I wrote down just says it's undefined if x is 2. So this is just a line with a hole in it. It's undefined at 2. There's no point there. There's a hole. Other than that, it's just x plus 2, which is this line. Okay? So, well, okay. We knew it. We said, before I drew the picture or anything, I said it's not continuous at x is equal to 2. Okay. Obviously, well, because there's a hole in it. It's not solid and continuous. It's not continuous at 2 for that reason. Okay. What about, let's do the math, remember? Got to do the math. I need to hold you accountable for that. So, as far as the math goes, what 3 things have to happen for it to be continuous? I've got to get an answer when I plug 2 in. The limit as x goes to 2 has to also have an answer. Third and last part, the answer you get on 1 must be equal to the answer you get on 2. Okay. It's going to fail one of these because, in fact, it's not continuous. So, first part of the test, what is f of 2? In this function, what do you get when you plug in 2? You don't get anything. It's undefined. Okay. Well, so that means it fails, the first part. What about the limit? Does it at least pass that part? I mean, I know just from it failing the first part, it's not continuous, but we should still know how to do this limit. What's the limit as x goes to 2? According to these points being what they are, if the x was close to 2, where would the y be? If the x is anywhere near 2 at all, it will put the y's close to 4, no matter what. So this limit does have an answer. It's 4. Okay? Is this in conflict with plugging 2 in and getting undefined? No, that x arrow 2 does not mean x equals 2. It means what if x was close to 2? That would put the y's close to 4. We can see that much from a graph, or if we made a table. If you made a table and put in 2.1, 1.9, you would see that you get answers very close to 4 for y. Okay? So it does pass that part, but it fails the last part because undefined is not equal to 4. Okay. All right. But let's make sure that we can make our conclusion about it being continuous or not either way. So I want to do one more like this. And then show you something a little bit different. So let's take this one. So question's the same, and I think it would say something like, is this continuous at 2? Yes or no? And let's just sketch it and do the math and make our judgment uniformly from both of them. So let's see. I need to draw, let's do this. Y equals 3 if x is less than or equal to 2. That means if x is 2, y is 3. Right, to that point right there, it's filled in, etc. But if x is less than 2, y is still 3. So if x is 1, it's 3. If x is 0, it's 3, etc., etc. Okay, so that's this one. What about this one? Y is x plus 1 if x is greater than 2. So what should our first point be right there? Let's put 2 in, even though you're not supposed to. 2 plus 1 is 3. This one, I mean, that point would be open technically on this one, but it's going to be filled in on that one. It's picking up right there, and then it's going off in this direction. There's the line, x plus 1 if x is greater than 2. Is it continuous at 2? Yeah, I mean, yes. Look at it. My judgment, my answer. It is continuous at x equals 2. Okay, there's no missing points, there's no hole, there's no break in the graph, it's in one solid piece. All right, so okay, what's the math that we need to learn to support that? First thing that has to happen, f of 2 has to have an answer. F of 2 is 3. Okay, so check. Second thing, limit x goes to 2, f of x has to also have an answer. Well, if x is near 2, y will be near 3, no matter what. Okay, so that one's 3. So it passes that part of the test. What was the last part? The answer you get for 1 has to be the same as the answer you get for 2. Well, 3 is equal to 3. Okay, it passed all 3 part of the test. Now remember, I said that, 1, you could graph it. You could see if it looked continuous. But as far as the math goes in the test, if it passed each part, it would be continuous. Well, it looks continuous. It passes each part of the test. They're in agreement. It's continuous at 2. Okay. All right. So let's do something like with this behind us. Let's do something different. Look at this. It says, so I have this function. K is some unspecified number. All right. Doesn't say what it is. Like 4x minus k does not say what k is. What should k be for the function to be continuous everywhere? So here's how I want you to think about this. If this function was to be not continuous, if there was going to be some kind of a break in the graph here, it would be at the 1. Like maybe this doesn't pick up where that leaves off or something like that, okay? So what I'm thinking is like roughly at 1, like say you had 2x plus 1 for x less than 1. You know, that's going to be some kind of line, right? So here's 2x plus 1. And it's going to be open right there at 1. And then 4x minus k. That's going to be some other kind of a line. It's going to be defined right there. That point's going to be closed because you can have x greater than or equal to 1. Now, all right, so like maybe these two are disjoint. Maybe they don't meet in the middle at 1. Or maybe they do. I just need to fix the k so that this is down there. Okay? That's what I need. You know, if this was right there, it would be continuous. 2x plus 1 would leave off at x is equal to 1, right where 4x minus k picked up. Okay? Now, as far as math goes, what would put this point right down there? Well, when x is 1, I need this 2x plus 1 to be equal to that, 4x minus k. That would be putting this down there, picking up where this one leaves off, right at 1, which is where there could be a break depending on what the number k was. Okay, so it's just going to come down to solving this. So we'll put 1 in for x. 2 times 1 plus 1 equals 4 times 1 minus k. This turns out to be 3. And 4 minus k. And then we'll get negative 1 equals negative k, or k is equal to 1. Okay, so that's my number. If that was 4x minus 1, this would be continuous if we sketched it, if we drew it, etc. All right? Okay. But I just, I want you to see that, this thing which would obviously have to happen for it to be continuous, this is going to have to be down there, is the same thing as how I set it up. At 1 for x, that and that have to be equal. All right? Okay, so I hope visually and as far as the equations work, you can see some agreement there. Let's look at maybe 2 more like this. Okay, so here, like take this one, same type of problem. K is some unspecified number. It says, what should k be for the function to be continuous everywhere? Well, I could think of it like the last one, where like if I had x to the 3rd power, like whatever that looks like, and let's not worry too much about its exact shape, okay? This picture is completely generic. I'm not saying that this is to scale or that it has the actual shape of the graphs, but x to the 3rd power would look like, go up to like that, and that point would be open, right? Because 2 is not included. But then this one, kx minus k, could pick up somewhere else and then go off in that direction, right? So this is x to the 3rd power. That point has to be open because it's just less than 2. And this is kx minus k. This point has to be open because that's just bigger than 2. Now, even if you could, say, find a way to make sure this picked up right there, you would still have this hole in the graph. I mean, no matter what k happens to be, f of 2 is undefined. I mean, there's no way you can make this continuous. Okay? It doesn't matter what k is. With the problem I just did, you know, if we could run through all these scenarios, with k being different numbers, would just shift this line up or down. It turns out if k is 1, it puts it right there, picking up exactly where the other one leaves off, making it continuous. But like, no matter what, you're not going to get an answer when you plug 2 in. It doesn't matter where you shift that. You can move it down there, but it's not going to make it solid. Okay? So we'll say this one is not possible. Okay? Can't be done. Can't be made continuous. Why? Well, because f of 2 is going to be undefined. There's going to be a hole in the graph no matter what k is. Okay? Alright, which is what I tried to illustrate in the picture, but make sure that we can agree that there's no way to make this continuous. No matter what you think k should be, it just cannot be done. Alright? Okay, so let's look at this one. Now, I'm not going to redraw pictures and that sort of thing, okay? Because it's like the concept's the same. We need these to agree with each other at that split, okay? So I need x to the third power to be equal to k times x plus 5k if x is 2. This one's going to have to leave off where that one picks up at 2. You'll adjust the number k so that that happens. You'll solve for it. If I put 2 in, I'll get 8. I'll get 2 times k. I'll get 5 times k. All right? I'll get 8. And I'll get 7k. All right, so here's what that number has to be. It has to be 8 over 7. Okay? If that's 8 over 7x plus 40 over 7, then this one leaves off exactly where that one picks up. Okay? And then it would be continuous. All right. Okay, so I hope you see some common elements to those three. Let's do a few more now that are a little bit different. Okay. All right, so let's look at this problem, and I need to think about the instructions a little bit before I do it. But it says you have this function, and it's not continuous at 2, just as it is. All right, but can you give me a number in such that if you plug 2 in for x, you got in for y, and that would make it continuous? All right? So in other words, like, how could you define or redefine f of 2 so that it would be continuous? As it is, it's not. But how could you redefine your answer at 2 to make it continuous? Now, I think at this part, like, the best way I can show you is by showing you the picture. It's easier to show you than tell you, so I'll show you. If I was to draw this, it would be the line x plus 1 leaving the point 2 off. So it'd be leaving this point 2 for x, 3 for y. Okay? And otherwise it'd be a straight line, like that. And then it says, in addition to that, y is 5 if x is 2. So let's go up here at 5, and we got to have this point, and it's not continuous. We can look at it. It is not continuous at 2. But wouldn't it be continuous if this point was down there? If that point was right there, it would be one solid line, and it would be continuous. So what should y be when you plug 2 in to make it continuous? Well, all right, I'm going to look at that graph. It will be continuous at x is equal to 2 if f of 2 was 3. Okay, so I could give the answer that way, I guess the way the question's worded, it just says, tell me what that number, that output, that y needs to be. So you could also just answer it by saying n needs to be 3, okay? If you want to answer the question directly to the way it was asked. But no matter how we answer, can we agree that, yeah, if that point was right there, it would be continuous. So that means it would be continuous if f of 2 was 3, okay? Would make it continuous. Okay, all right, so let's look at another one to compare with this one. Same style of question. I have something that's not continuous at 1. How can you redefine your answer or your point at 1 to make it continuous? Like maybe it's like that one where if f of 1 was like 5, it would be one solid continuous graph. You know, maybe you just need to move a point from where it is to where it needs to be or something like that. So it's like the other one. But let's see by looking at it if we can figure out the answer. Okay. All right. So to sketch this, I got to draw x plus 4 up until 1. So I'm going to get like 1, and that's going to take me up to 5, right? And that's going to be open. It's not defined at 1 right there. This line goes right up to 5, but we don't include the point 1 and 5. And otherwise it looks like this. It's a straight line. So there's